Hey everybody, so in the last video I demonstrated how to create D3 objects that are powered by data. But in that case, we didn't use the data in any way. That's what we'll do in this video. So I'm going to go back to just a single datum here. The data set only has 15. And in this case, we're giving an automatic hard-coded radius of 15, cx of 100 and cy of 100, and we see that the circle, a single circle appears on the SVG. Now let's make it dependent on the data itself. So just to demonstrate that, I'm going to change the data to 30. See that it still stays with a radius of 15 here. And in this case, we can pass a callback, which is just a function that's passed into another function, into this method here instead of the 15, and that will allow us to do what I just described. So you can use either ES6 syntax here, which I will do, or you can use just default function style like this. So instead of that, which you'll see oftentimes, I'm going to go ahead and use, like I said, ES6 syntax. So here we will take in a variable called D. Now, it doesn't have to be called D, but by default, you'll see that it's called D throughout any D3 examples you'll see out there. And that just means a datum, just a single piece of data. And it will be equal to whatever that is powering is embedded within that circle. And in this case, we saw in the previous demonstration that we created one circle based off of this data, and if we had multiple data points, we'd end up with multiple circles, each embedded with a corresponding data point. So if we had 30 here and then 15, the first circle would be embedded with 30, the second one would be embedded with 15. In this case, let's stick with just one, but this 30 is infused within this circle. We just haven't been using that 30 at all. This is how we use it. So here we determine that the radius will be equal to, let's just start with straightforward. It'll be equal to the data point itself. So in this case, the data point is 30. So great, let's see what that looks like. Because this has a radius of 15, as soon as we refresh this, we expect the circle to increase in size to 30. There we go, great. Now, just to reflect that a little bit more concretely, we can make this D equal to, let's say, whatever the data point is times 2, in which case this should double in size to 60. There it is. And our SVG is a little bit small here, so I'm going to increase the SVG size. We'll give it an attribute height of, let's say, 1,000 pixels, 1,000 pixels, and we'll give it a width of 100%. Great, so we can see it in its entirety. Now, here we're multiplying the data point and defining the circle's radius as the data point times 2. If we were to change this to 50, the radius would be equal to 100. There we go, we see that there. If we were to change this to multiply by 1/2, we'll see that it'll then be equal to 25. 50 times 1/2 is 25. There you go. Now, really to see the power of this, let's go ahead and create multiple data points. So we'll do 1, 2, 3, 4, 5, 6, 7. Wonderful. So now we'll make the radius equal to, let's say, the data point times 10. So the first one will have a radius of 10, then 20, then 30, then 40, etc. And then let's make, actually, let's just go ahead and do that. There we go. So now we have multiple circles here, all of different radius sizes. Problem is, they're all on top of each other, so we can't really see them. So let's make their position also dependent on the data point. So in this case, we'll give another callback here, D, and its position will be, let's say, D times 15, let's say. And then same thing for Y, D times 15. Let's try that. There we go. So its position is also dependent on the data point. So those that, this circle infused with the 7 data point is going to be further out, 7 times 15. So there's our example. 7 times 15 is 105, and we see that they spread out. Let's make them actually more apparent. We'll make them more spread out, and we'll see that. There we go. We could go even further. You get the idea here. Wonderful. So now we learned how to make a visualization powered by the data, not only infusing creating a circle for each data point, but also making the attributes of that circle dependent on the data point itself.